Collecting sample data. The method used to collect sample data influences the quality of statistical analysis. If sample data are not collected in an appropriate way, the data may be useless. SR is known as simple random sample. In short, to explain that, when we look at random sampling, that means every subject has an equal chance of getting picked. But simple random sample means every sample of the same size has an equal chance of getting picked. So that's the basic definition of that. Statistical methods are driven by the data that we collect. We typically obtain data from two sources, either observational studies or experiments. As far as the golden standard is that we normally want to look at randomization, and it is sometimes called the gold standard because it is highly effective, and we'll discuss that further. So we have observational study and we have an experiment we want to discuss.
Observing and measuring specific characteristics without attempting to modify, influence the individuals being studied. In an observational study, the researcher merely observes and tries to draw conclusions based on the observations.
Okay, so that's the definition of observational study. We just observe and we make a note of what happens.
Apply some treatment and then proceed to observe its effects on the individuals. The individuals in experiments are called experimental units, and they are often called subjects when they are people. In other words, an experiment is a controlled study that aims to determine the effect of one or more explanatory variables or factors on a response variable. Any combination of the values of the factors is called a treatment. The researchers manipulate the independent explanatory variable and tries to determine how the manipulation influences the independent outcome response variable in an experimental study.
So observational studies do not lead to a claim for causation. They can lead only to what we call an association. Let's quickly look at an example.
Back pain treatment. In a study to test effectiveness of a drug for back pain, 1,643 patients were randomly assigned to. Group 1, placebo, pills with no medication, 547 subjects. Group 2, pain medication taken at regular intervals, 550 subjects. Group 3, pain medication taken as needed for pain, 546 subjects.
Placebo, normally when we deal with medication, some patients receive no medication. What they given is called placebo. Basically, what is this? Is this an observational study? Is this an experiment?
Experiment.
It's an experiment. Clearly, it's an experiment. We gave him some treatment.
A physician's health study involved 22,701 male physicians. They randomly split them in half. Half of the physicians were treated with aspirin and the other half were given placebos.
So what do we have here?
Experiment.
Clearly, we have an experiment. Now, in this case, to a certain degree, it may be subjective, but when it's asking, is there any problem? When you look at this one, we just dealt with male physicians. So one might ask why. Perhaps you want to include female physicians.
Blood pressure. A researcher selected 4 males and 4 females to test for a difference in systolic blood pressure levels between males and females who are 12 years of age.
So what do we have?
Observational.
And obviously, there is a problem here. The problem is the sample size is too small. If you're checking on blood pressure, you really want to look at a lot more, a sample size which is a lot more than just 4. Let's read the next page.
An experiment is a controlled study that aims to determine the effect of one or more explanatory variables or factors on a response variable. Any combination of the values of the factors is called a treatment.
Next.
The experimental unit or subject is a person or object which treatment is applied. A control group serves as a reference point treatment that can be used to compare the other treatments. A placebo is a harmless medication, such as a sugar tablet that looks, tastes, and smells like the experimental medication with no medicinal effect.
Next.
A lurking extraneous variable is a variable that has an important effect on the relationship among the variables in the study, but is not one of the explanatory variables studied. It is one that is not considered in a study. A confounding variable. Two variables are confounded when their effects on a response variable cannot be distinguished from each other. A confounding variable influences the dependent variable but cannot be separated from the independent variable.
One thing I want to explain, sometimes it's very difficult to distinguish between the two. The idea is that normally there is a variable that you are studying. So for example, the blood pressure is being studied, okay? And so the variable that you give it, the independent variable could be the pill that you give it and the placebo. So that is the independent variable, and the variable is there is a dependent variable is the blood pressure. And there may be other variables. In fact, there are other variables that will affect it. There are maybe a lot of variables. Some of them are called extraneous. They are just other variables, extra variables that will affect that. But the study is not considering that because the study is concerned with something else. The effect of, for example, that specific pressure medication. Or there may be variables that are confounding or confusing in essence that we can't separate the effect of one from the other. So it's very important to know when you set up an experiment, things have to be done with close attention and those who have, experience that can help. So in any event, these are some definitions that I wanted to mention. What is the next one?
Replication is the repetition of an experiment on more than one individual. We can see effects of treatments through usage of large sample sizes. Randomization is used when subjects are assigned to different treatment groups through a process of random selection. Use chance to create groups that are similar and minimize the effects of variables whose level cannot be controlled. Therefore, randomization is to averages out the effect of uncontrolled predictor variables.
So replication, repeated, random. The random process is extremely important. And finally,
blinding is a technique in which the subject doesn't know whether he or she is receiving a treatment or a placebo. Blinding is a way to get around the placebo effect, which occurs when an untreated subject reports an improvement in symptoms. Double blind. Blinding occurs at two levels. The subject doesn't know whether he or she is receiving the treatment or a placebo, and the experimenter does not know whether he or she is administering the treatment or placebo.
So the blinding is important, and the idea is that we don't know whether we are getting the treatment or not, and that's blinding. If we don't know, and those who are in charge, they don't know it either, then it's double blinding. And as I mentioned, this is an example that a research scientist studies the effect of diet and exercise on a person's blood pressure, lurking variable and extraneous variable that also affect blood pressure, or whether a person smokes and stress level. So there are others that we may not consider in this study, and they will affect it. So let's do this one, and we quickly take a few minutes of break, just in case if anybody needs it, because I don't want anybody to leave in the middle of the Zoom session.
A math department is planning to offer an online version of the statistics course. They randomly split a section of the course, and half of the students are placed in the traditional course and the other half in an online version. At the end of the semester, both groups will be given a test to determine which performed better.
So we want to answer this question by looking at various parts. So who are the experimental units?
The students taking the course.
What is the population for this case?
The students who enrolled.
In what course? Stats, okay. All right, so students in the course. Which course? Statistics. What are the treatments?
Online versus traditional instruction.
What is the response variable?
The test.
That is the dependent variable. Just refer to the basic linear equation that we have learned in algebra. Y equals mx plus b. Remember, y is the dependent variable, x is the independent variable. Everybody remembers that, right?
Yes.
Can we do it with blinding?
No, because the students and the teachers will know whether they're teaching online or in class.
There's nothing you can do. Okay, you are in class. Okay, you know if it's online or not. The teacher who's teaching it knows the same. All right, we are going to look at collecting sample data. In this case, simple random sample, also known as SRS.
A sample of n subjects is selected in such a way that every possible sample of the same size, n, has the same chance of being chosen. Random sampling is the process of using chance to select individuals from a population to be included in the sample. A simple random sample is often called a random sample, but strictly speaking, a random sample has the weaker requirement that all members of the population have the same chance of being selected.
Random sampling simply means every subject has an equal chance of being picked. Okay. Just for the sake of argument, if we have 50 students and 30 students are females, the probability of picking a student to be female would be 30 out of 50. That's the idea behind that. But simple random sampling refers to the fact that every sample of the same size has an equal chance. So just for the sake of argument, so you see how that works. If you have 50 students and we want to pick 5, a sample 5. So we want simple random sampling. That means every sample of the same size must have an equal chance. That's the idea. Now, if you have 50 students and you want to pick 5, how many different ways can we pick 5? Anybody?
You can go every 10%, you can do the first 5, last 5, middle 5. I mean, there's lots of ways you can do it.
So, lots of ways we can do it like that. Okay. That's right. There's a lot of ways. How many ways? Anybody knows that?
Does the order in which we pick them matter?
No.
It should be over 2 million.
It's a combination of 50, choose 5. Yeah, very good. So it's a combination. You're right. Order is not important. Some sampling techniques. So it's important to understand it's really not that simple. If you have 50 students and you want to pick 5, it's got 10 different groups. It's a lot more than that because pick any 5 and all you have to do change one subject and you have a new sample. Random, you can use a random number generator. Systematic, this is a very simple way of defining it. Every kth subject, we will look at it with more details. Stratified, you divide population into homogeneous groups and then pick from each group a few. Whereas cluster means divide population into non-homogeneous group and use all in those groups. Convenient sampling, okay, you are sampling. One convenient sampling for me would be to ask my own students what they think of a specific question. So for mall survey and you name that.
Systematic sampling. Select some starting point and then select every kth element in the population.
So that's the idea behind systematic sampling. Next.
Stratified sampling. Divide the population into homogeneous subgroups called strata, and then obtaining a simple random sample from each stratum.
That's the idea, okay? And you pick a few from each. So take a look at the way this is done versus cluster sampling.
Divide the population area into sections or clusters, non-homogeneous subgroups, then randomly select some of those clusters and choose all the members from those selected clusters.
So stratified sampling, they are the same. You pick a few from each cluster. They are different. You pick a specific cluster or maybe a few of them, and you pick all of the subjects. Convenient sampling, obviously, when you go with the easy method, such as survey, and multi-stage sampling.
Collect data by using some combination of the basic sampling methods. In a multi-stage sample design, pollsters select the sample in different stages, and each stage might use different methods of sampling. It is more practical for large-scale surveys to obtain samples using a combination of the techniques discussed.
Good. Okay, the techniques that you really should know was the first one, the first 4 that we discussed. The multi-stage sampling normally happens when we have a large sample size. One of the things that sometimes students confuse is between stratified and cluster sampling. And I found that this example might help them understand this better. And that is, if you are collecting a sample from the class that want to be representative of the class as far as the grade is concerned. Let's just say, for the sake of argument, we have A's and B's and C's. We have a couple of ways to do that. One is that we put all the A's in one group, all the B's in one group, all the C's in one group. Then from each of those groups, we pick a few. How many? Depending upon which one is more. Okay, for example, if you have more A's, you pick more A's accordingly. So those are the same. All of them are A's, all of them are B's, all of them are C's. The example I just mentioned is stratified sampling. So you have A's, you have B's, you have C's, and you pick a few. That would be stratified. The other method is that you put A's and B's and C's, okay, randomly you select them, you put a few in each. Just as an example, I'm just showing 3, but there may be more. And then randomly you assign it to each group, and then randomly you select one group, for example. That would be a cluster. Depending on the size, you may need more than that. Yes, go ahead.
I just have one question for the cluster
Yes,
sampling. I get that you make the subgroups like ABC, ABC, but can the subgroups themselves have the same like homogeneous members? Like let's say you do AAB or like ACA. Like can they have the same members?
In stratified sampling, all of them are A's, all of them are B's, all of them are C's in 3 different groups, and you pick a few from each group. In cluster sampling, the first group, they have A's and B's and C's. So does the second group, so does the third group. In other words, if you look at the first group, there are not A's. They are representative of the class to begin with. So if you pick any of them, any of those groups should do the job, did I? So the idea behind the cluster is that, let's say we have only 3 groups now. If you pick any of them, is really good to represent the class. Now, which one do you pick? You pick it again randomly, okay?
Thank you.
A survey was emailed to 5,000 people asking for which ear is used for cell phone calls and which hand is the dominant, and 717 were returned. A, what type of sampling is used? Does it affect the result? B, is this an observational study or experiment? C, what is the response rate in percentage? Is it low? In general, what is the problem with the very low response rate?
So what's the answer to part A?
Self-selected voluntary sampling.
Absolutely, it's convenient sampling, yeah, because we are doing the survey and it is self-selected, you're right. And so what about part B?
Observational.
There's nothing that we are changing. There are no treatment involved. And so what about part C? How do we calculate that?
You don't you divide like 717 by 5,000?
Perfect. Okay, and that's about 14.34%. It is low, but depending on the subject of interest, it is biased because people just answer if they are interested in the subject. All right, let's look at the first one. Let's say example number 4, the first one, number 10.
The sexuality of women was discussed in Sheer Heights' book, Women in Love, A Cultural Revolution. Her conclusions were based on sample data that consisted of 4,500 mailed responses from 100,000 questionnaires that were sent to women.
So what do we have here?
Convenience.
The next one.
UFO poll. In a Kelton research poll, 1,114 Americans 18 years of age or older were called after the telephone numbers were randomly generated by a computer. And 36% of the respondents said that they believe in the existence of UFOs.
Perfect. So what do we have here?
Stratified.
It's a basic random sampling. Perfect. Next.
The author surveyed the sample from the population of a statistics class by identifying groups of males and females, then randomly selecting 5 students from each of those 2 groups.
Perfect.
Stratified.
Stratified.
Beautiful. Next one, please.
Satellites are used to collect sample data for estimating deforestation rates. The Forest Resources Assessment of the UN Food and Agriculture Organization uses a method of selecting a sample of a 10-kilometer wide square at every 1 degree intersection of latitude and longitude.
So what do we have here?
Systematic.
Very good. Every Kate one, if you will. Last one.
Exit polls. During the last presidential election, CNN conducted an exit poll in which specific polling stations were randomly selected. All voters were surveyed as they left the premises. Sorry.
Sure. Thank you so much. And
So
the
it's
answer
random?
is
Cluster.
it's a cluster. Okay, class. It's a cluster based on what we have defined cluster to be. Okay, we divide the population into sections. Okay, that are non-homogeneous. Okay, and then we randomly select that, and then we choose all of them, and the whole cluster is chosen. All right, we have types of observational study.
Data are observed, measured, and collected at one point in time, not over a period of time.
The next one.
Retrospective or case control study. Data are collected from a past time period by going back in time through examination of records, interviews, and so on. In case control studies, individuals who have certain characteristics are matched with those that do not.
Last one.
Perspective or longitudinal or cohort study. Data are collected in the future from groups sharing common factors called cohorts.
So, with that being the case, the synopsis of that is given at top here, cross-sectional, basically at one point in time, retrospective, past time period, and prospective future cohort. All right, so the first one, could somebody read the first one, number 30?
Heart health study. Samples of subjects with and without heart disease were selected. Then researchers looked back in time to determine whether they took aspirin on a regular basis.
Thanks. What do we have?
Retrospective.
Okay, next.
Marijuana study. Researchers from the National Institutes of Health want to determine the current rates of marijuana consumption among adults living in states that have legalized the use of marijuana. They conduct a survey of 500 adults in those states.
Cross-sectional, again, based on the definition. And the last one.
Framingham Heart Study. The Framingham Heart Study was started in 1948 and it's ongoing. It's focused on heart disease.
So let's see. It's ongoing. So basically, you look for a keyword and you have the answer. All right, let's go to the next one.
Matched pairs design. Compare two treatment groups by using subjects matched in pairs that are somehow related or have similar characteristics. The same person before and after treatment, twins, husband and wife, same geographical locations, and so on. Lunesta. Lunesta is a drug designed to treat insomnia. In a clinical trial of Lunesta, amounts of sleep each night are measured before and after subjects have been treated with the drug.
So clearly that's a matched pair. Does that make sense?
Yes.
A randomized block design is used when the experimental units or subjects are divided into homogeneous or similar groups called blocks. Within each block, the subjects are randomly assigned to treatments. Normally, blocks differ in ways that might affect the outcome of the experiment.
Lipitor. A clinical trial of Lipitor treatments is being planned to determine whether its effects on diastolic blood pressure are different for men and women.
That's a randomized block design. This one, it's put it up first, rigorously controlled design. It's hard to do, and we're not going to, bother with that too much. Carefully assign subjects to different treatment groups so that those given each treatment are similar in ways that are important to the experiment. That is not easy to do.
Completely randomized experimental design. Assign subjects to different treatment groups through a process of random selection.
Nile vaccine. Currently, there is no approved vaccine for the prevention of infection by West Nile virus. A clinical trial of a possible vaccine is being planned to include subjects treated with the vaccine while other subjects are given a placebo.
So this is a completely randomized experiment design. Now, when we look at the next page and it's coming up, we have really a good illustration of this. So I want to quickly spend a couple of minutes explaining what we just went over. You have the definitions, you have a couple of examples, and you have the solution. So what I want to look at is the next page that sort of explains this a little bit better because visualization is important. So here's the design of experiment. Look at part A. We are treating all women subjects and give the men a placebo. So it's definitely not a good idea. So one group gets the treatment, the other one doesn't. Whereas in part B, we use completely randomized experimental design. We use randomness to determine who gets it and who doesn't, who gets the treatment and who doesn't. And randomized block design form a block of women and a block of men. And within each group, select the subjects that get the treatment and those who don't. And of course, as far as the matched pair design that was discussed, get measurements from the same subjects before and after some treatment. For example, if you're looking at the effect of blood pressure medicine before and after for some person. So that's the idea behind it. Now I'm going to look at the last page that I want to discuss for you today. So here we go.
No matter how well you plan and execute the sample collection process, there is likely to be some error in the results. A sampling error or random sampling error occurs when the sample has been selected with a random method, but there is a discrepancy between a sample result and the true population result. Such an error results from chance sample fluctuations. It results from using a sample to estimate information about a population and is due to the fact that a sample gives incomplete information about a population.
How about this one?
Non-sampling error is the result of human error, including such factors as wrong data entries, computing errors, questions with biased wording, false data provided by respondents, forming biased conclusions, or applying statistical methods that are not appropriate for the circumstances.
Finally,
non-random sampling error is the result of using a sampling method that is not random, such as using a convenient sample or a voluntary response sample.
So in short, the two things that are important, the sampling error and the non-sampling error. Okay, the sampling error is very simple. It is a sample versus a population. And obviously, there might be some error due to the fact that you're dealing with a portion of a population. The non-sampling error is normally when we record and we make mistakes.